Hi everybody. Come, let's go with the solution method. That means the most talked about techniques for the solution of the unit commitment problems are priority list schemes, dynamic programming, that's called DP, Lagrange relations, that's called LR. Come, let's go with priority list method. The simplest unit commitment solution method consists of creating a priority list of units as a simple shutdown rule or priority list scheme could be obtained after an exhaustive enumeration of all unit combination at each load level. The priority list of example could be obtained in a much simpler manner by noting the full load average production cost of each unit, where the full load average production cost is simply the net heat rate at full load multiplied by the fuel cost. Priority list method is the simplest unit commitment solution, which consists of creating a priority list of units, full load average production cost always having net heat rate at full load x fuel. Cost assumption is no load cost is 0, unit input output characteristics are linear between 0 output and full load. Startup cost area fixed amount. Ignore minimum uptime and minimum downtime steps to be followed. There is determine the full load average production cost for each units. Form priority order based on average production cost. Commit number of units corresponding to the priority order. Calculate PG1, PG2, PGN from economic dispatch problem of the feasible combination or startup cost and the all over fixed economic dispatch cost. Then we have to see dynamic program method or dynamic programming solution. Dynamic programming has many advantages over the enumeration scheme. The chief advantages being a reduction in the dimensionality of the problem. Suppose we have found units in a system and any combination of them could sever the load. There would be a maximum of 24 minimized 1 equal to 15 combination to test. However, if a strict priority order is imposed, there are only 4 combinations to try. Imposed priority 1 unit is priority 1 unit plus priority 2 unit. Then priority 1 unit plus priority 2 unit plus priority 3 unit. Third one is priority 1 unit plus priority 2 unit plus priority 3 unit plus priority 4 units. The imposition of a priority list arranged in order of the full load average cost rate would result in a theoretically correct dispatch and economic commitment only. If no load costs are 0, unit input output characteristics are linear between 0 output and full load. There are no other restriction. Then startup cost or a fixed amount. In the dynamic programming approaches that follows, we assume that a state consists of an array of units with specified unit operating and the rest of line. The startup cost of a unit is independent of the time it has been offline. Third one is there are no cost for shunting down a unit. Fourth is there is a strict priority order, and in each interval a specified minimum amount of capacity must be operating. A feasible state is one in which the committed units can supply the required load and that meets the minimum amount of capacity each period. Third one is forward DP approach, that is forward dynamic programming approach. One could set up a dynamic program algorithm to run backward in time starting from the final hour to be studied back to the initial hour. Conversely, one could set up the algorithm to run forward in time from the initial hour to the final hour. The forward approach has distinct advantages in solving generator unit commitment. For example, if the startup cost of a unit is a function of the time it has been offline, that means its temperature, then a forward dynamic program approach is more suitable since the previous history of the unit can be computed at each stage. There are other practical reasons for going forward. The initial conditions are easily specified and the computations can go forward in time as long as required. A forward dynamic programming algorithm is mentioned the traveling salesman problem across the unit data. So both the diagram and unit data having some basic requirements of this unit commitment sectors. Thank you.